Now we are going to prove that the root 5 is irrational. How to prove? So let us assume to the contrary that root 5 is rational, right? So you know that all rational numbers can be expressed in the form of a by b, where a and b are integers and b is not equal to 0 and a and b are co-prime. What is an integer? A set of integers is minus numbers from minus 10, minus 9 like that, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 like that it will be going on. Then b is not equal to 0. What does that mean? B is not equal to 0. When b is 0, then this number will become a not defined number. Okay, so b should not be 0 and a and b are co-prime. So you should understand the meaning of co-prime here. What is co-prime? The co-prime numbers are such that they should have HCF equal to 1. For example, you take 3 and 5. Prime factors of 3 is 3 into 1, 5 is 5 into 1. What is common between 3 and 5 will get 1. When HCF is 1, they are called co-prime number. For example, you take 6 by 25. Prime factor is 6, 3 into 2 into 1, 5 into 5 into 1. Here in the numerator and denominator, the common number is 1. So the HCF is 1. So when the HCF is 1, they are called as coprime. Here we can conclude that the HCF of A and B is 1 because we are just stating here that A and B are coprime, right? Now going to the next slide. Now root 5 equal to A by B. Root 5 equal to A by B. Squaring on both sides. Square on both sides you will get root 5. When you square you will get 5. A square by B square. Cross multiply 5b square equal to a square. So b square equal to this 5, it go that side, a square by 5. From the above, a square is divisible by 5. Then by theorem, if p is a prime number and p divides a square, then p divides a also. So a is divisible by 5. A is divisible by 5. And now we proved that a is divisible by 5, right? Now let us take a equal to 5c. Apply it in 1. So 1, when you apply, 5, this is 1. 5b square equal to a square is the first equation. 5b square equal to 5c the whole square. 5b square equal to 25c square. So 25c square by 5 equal to b square. So cancel 5 and 25, you will get 5c square equal to b square. So c square is 5, it go that side, b square by 5. From the above, b square is divisible by 5. Then by theorem, if p is a prime number and p divides a square, then p divides c. P is divisible by 5. B is divisible by 5. See, first we told that a is divisible by 5, then b is divisible by 5. But in the beginning, we told a and b are co-prime, that they are having HCF is 1, right? But here now we got both the numbers are having a same common number 5, that is HCF is 5. As a and b both divisible by 5, they are not co-prime as they are having a common factor other than 1. This contradiction occurs as our assumption is wrong. That is, we have assumed that root 5 is irrational. So we can conclude that root 5 is irrational. Okay, now going to the next one. Prove that 2 minus root 3 is irrational. Take 2 minus root 3 equal to a by b and a and b are integers. B is not equal to 0 and a and b are co-prime. Right? So take this to that side. When plus 2, if it go that side, minus 2. Here minus root 3 is there. Minus root 3 equal to a by b minus 2. As I want to make it as a plus root 3, I want to change the sign of equation fully. This minus root 3 will become plus root 3. A by b will become minus a by b. Minus 2 will become plus 2. Now I am writing this as 2 minus a by b. Simply I am taking 2 this side, that's all. Okay. 2 minus a by b. Taking LCM, I will get root 3 equal to 2b minus a by b. So we know that root 3 is rational. But we have assumed 2b minus a by b is rational. The above contradiction occurs as our assumption is wrong. So 2 minus root 3 is irrational. Okay. In the same way, you can prove for 15 plus 7 root 2. Here 7 root 2 equal to a by b minus 15. Root 2 equal to a minus 15b by 7b. So here root 2 is irrational, but we took that, assumed that 15 plus 7 root 2 is rational. According to that, this is rational. This contradiction occurs as our assumption is wrong. So 15 plus 7 root 2 is rational. Okay. Now going to the next problem, 6 root 7 is irrational. So we let us assume 6 root 7 is rational. 6 root 7 equal to a by b, where a and b are integers, b is not equal to 0, a and b are co-prime. 6 root 7 equal to a by b, root 7 equal to a by 6b. Root 7 is rational, but this is rational. The above contradiction occurs as our assumption is wrong, so 6 root 7 is rational. So this proof is very important. You just read this fully and write and practice it again and again.